Okay, today we're going to be talking about the 6 trig functions of theta. So, some of them, actually the first 3 you already know. So the first one is sine. And we know sine is abbreviated SIN. According to SOHCAHTOA, the sine is the opposite over the hypotenuse. On the unit circle, the sine is the y value. And on a circle with radius not equal to 1, it's the y value over the radius. The difference between it being on the unit circle and being on a circle of radius other than 1, this is really y over r, but r is equal to 1. Okay, then we had cosine. So cosine, if we look across here, cosine, according to SOHCAHTOA, is adjacent over hypotenuse. On the unit circle, it's the x value. If it's not on the unit circle, it's the x over the radius. Now, tangent. So we know tangent to be, according to SOHCAHTOA, tangent is the opposite over the adjacent. On the unit circle, it's the y over the x. Or you could look at it as the sine over the cosine, because the sine is the y and the cosine is the x. On the units, if it's not on the unit circle, it's still y over x. So what happened to our radius? Well, it's the sine over the cosine. So it's y over r over x over r. But instead of dividing by x over r, we multiply by the reciprocal, r over x. The r's cancel, and the radius goes away, so it's simply y over x. And the reason that is because SOHCAHTOA, according to SOHCAHTOA, it's the opposite over the adjacent. On our unit circle, if I draw over here, well, the radius is in a very straight line. It is the y values here, the x values here, and the r is the hypotenuse. So as you can see, the hypotenuse plays no role in the tangent. Okay, so now to the ones that are new to you. We have something called the cosecant, which is abbreviated CSC. The cosecant is defined to be the hypotenuse over the opposite. So if you look at it in relationship to sine, the cosecant is the reciprocal of the sine. So if the sine is the y value on the unit circle, it's 1 over the y on the unit circle. The cosecant's the 1 over y. If you're not on the unit circle, the sine is y over r, so the cosecant is r over y. Simply put, the cosecant is the reciprocal of the sine. Okay, so now we'll go ahead and look at secant. Secant is abbreviated SEC. It's defined to be the hypotenuse over the adjacent. So as you can see, the secant is simply the reciprocal of the cosine. So if the cosine is x, the cosecant is 1 over, the secant is 1 over x. If it's not on the unit circle, it's x over r for cosine, so secant would be r over x. And lastly is the cotangent. Cotangent is abbreviated COT. It's it's adjacent over opposite, which is the reciprocal of the tangent. So it's y over x for tangent, it's x over y for cotangent. Okay, and again, if the tangent is y over x, x over y, because the radius cancels out on these two. So let's look at our first example here. It says, given the point negative 1/5, comma, 2 root 6 over 5 is on the unit circle, find the 6 trig functions. Oh, that looks like it got erased a little bit. Find the 6 trig functions of theta. So the first thing we have to understand is what is theta. So I'm going to go ahead and give myself a coordinate plane right here. Okay, and I'm going to approximate where the point negative 1/5 2 root 6 over 5 would be on the unit circle. So let's just say it's about right here. Okay, I'm going to connect that point to the origin. And I don't know why on this whiteboard, whenever I try to write a diagonal, draw a diagonal line, it always comes out crooked. So we'll try that with something else here. We're just going to live with that. So I connected the point to the origin. Now I'm going to drop a perpendicular to the x-axis. And what I've done is I've created a right triangle of sorts. Theta is always the angle at the origin. So if we were to, this point right here represents the point negative 5th 2 root 6 over 5. So that means I would go along this axis, negative 1/5, and I'd go up the y-axis as 2 root 6 over 5. And this is 1, because it's on the unit circle. So when they say to find the 6 trig functions of theta, they're asking me what is the sine of theta? So the sine, according to SOHCAHTOA, is opposite over hypotenuse, so it would be 2 root 6 over 5 over 1, right? All over 1. But we know that that over 1 doesn't make a difference, so we'll just erase it. So do you see how the sine is the y value? Okay, then they're asking us for the cosine of theta. So according to cosine, or according to SOHCAHTOA, cosine is negative 1/5 adjacent over hypotenuse, but the hypotenuse is 1. So it's simply the x value. Okay, then they're also asking us for the tangent of theta. Now this one may take a little work. The tangent is opposite over adjacent. So the opposite would be, I'm going to just write over here for space, it'd be 2 root 6 over 5 over 1/5. So instead of dividing by 1/5, I multiply by 5 over 1. The 5's cancel. What's this root 6 here? And the 5's cancel, so my answer is 2. Oh, it's negative 1/5, sorry. So it's negative 2 root 6. Sorry, I was about to try to do better. Okay, so now we need the other trig functions. So the next thing we want is cosecant of theta. Now remember, the cosecant of theta is simply the reciprocal of the sine. So all you have to do is reciprocate the sine. So it's 5 over 2 root 6. Okay, If I rationalize that, I get 5 root 6 over 12. Okay, then we want the secant of theta. The secant of theta is simply the reciprocal of the cosine. So if the cosine is negative 1/5, the secant is negative 5. And then the cotangent of theta is the reciprocal of the tangent. So you'd have to put 1 over negative 2 root 6. And then you'd have to rationalize that. So it would be negative root 6 over 12. And that's how you find the 6 trig functions of theta. Okay, so now here's a problem for you to try. Given negative 2/5, comma, root 21 over 5 is on the unit circle, find the 6 trig functions of theta. So what I'd like you to do right now is pause the video, and when you have your answer, you can go ahead and restart the video and I will give you the answer. So pause your video now. So here are your answers. If you got them all, great job. If you didn't, go back and review the problem before. The point should lie in quadrant 2, just like the other point, and see if you can recreate it. Okay, thanks. We're going to do another video shortly with some more problems.